Hi guys, it's Virginia. I'm going to do a demo problem for the angle sum formula for tangents. We're given the sine of an angle A and the sine of an angle B, and we need to know the tangent of A plus B. So again, this is goes along with the formula or the problems you might encounter that in section 3.5 of the textbook, the angle sum formulas. Okay, so let's first just sketch out our triangles here to get our tangent values, because we're going to need the tangent of A and the tangent of B to plug into our formula. So I'm given the sine of angle A, so that's the opposite, and it's in the third quadrant, I'm told. So I know that the x-coordinate, the y-coordinate are going to be negative. So I'm just going to type in the opposite leg, the hypotenuse, which I always consider as positive here. And then I know that in quadrant 3, this x-coordinate's negative as well. And it's going to be, so it's negative, and it's going to be the square root of 3 squared minus 2 squared. So it's going to be square root of 5. Oops, I lost my negative sign. Okay. So there's my triangle. And I'm going to go ahead and plug in that the tangent was, so that's opposite over adjacent. So 2 divided by the square root of 5, the negative signs cancel. Sine and cosine are both negative, so tangent is actually positive. Okay, so angle B, the sine is 9/10, and I'm in quadrant 2 here. So opposite leg is 9, hypotenuse is 10, and then in quadrant 2, the x-coordinate is negative, and then we want the square root of 10 squared minus 9 squared. So that ends up being the square root of 19. So our tangent here is negative because the opposite leg is positive, and it's over the square root of 19, but the x-coordinate is negative, so the entire thing is negative. Okay, so now we have those values. What formula are we going to use to get the answer tangent of A plus B? Oops, tangent of A plus B. It's not highlighting for me. All right, so going to the textbook, I like to find the formulas in the slideshow, and it's just a really nice overview of the section and everything that you need. So we need this one right here, tangent of A plus B. So let's go and do this by hand. It's a little easier to see. So copying down the formula, tangent of A plus B equals tangent of A plus tangent of B divided by 1 minus the product tangent of A times tangent of B. Okay, so let's go ahead and just first use substitution. And that means we have tangent of A, we got to be 2 over the square root of 5, and then plus, and we got a negative for tangent of B because it was in quadrant 2. So this is our numerator, and our denominator is 1 minus the product of these, 2 divided by square root of 5 times negative 9 over square root of 19. So we have this kind of nasty, ugly, oops, didn't mean to get rid of that whole thing, ugly complex fraction, which it's nice to simplify in general. But I've discovered that actually in the mat tool, this will be okay for your final answer. So let's just try that real quick, and I'll show you how that works. All right. So in the numerator, let's get some parentheses here. We're going to have this kind of ugly expression. It's going to take me a minute to type out on an iPad. Minus 9 divided by the square root of 19. oops, I didn't mean to close my parentheses there. I'm going to close them here. And then that whole thing is going to be divided by 1 minus product of 2 divided by square root of 5. I'm going to get that cursor out. And then negative 9 divided by square root of 19. It's really important here to be very careful with your signs, especially with the fact that the signs always sort of change in nature in the formula itself. So just watch what formula you're using and the sign values of your ratios. So this actually is acceptable. I'm not being super strict with requirements for simplification in these particular problems. But a lot of times you would want to simplify this complex fraction, like on a test or a quiz maybe, or just to show nice calculations. So I'm going to also show that, but just know that this will work. So let's do that last part of simplifying. And I like to simplify the numerator and the denominator separately. So I'm going to start with the numerator. So I have 2 over square root of 5 plus negative 9 over the square root of 19. And I need to find a common denominator. So here I have square root of 5 and square root of 19. So the only way to really find a common denominator here is to just use their product. So I'm just going to do the square root of 5 times 19, which is the square root of 95. So that's going to be my common denominator. So I have to multiply this first term times this 1, which looks like the square root of 19 over the square root of 19. And then I'm just going to go ahead and use this. I'm subtracting it since I'm adding a negative. And here I have a denominator of square root of 19. So my weird looking 1 is going to be the square root of 5 times the square root of 5 over the square root of 5. Okay, so now here I have the same denominator, so I can simplify. I can combine the two terms that are in the numerator here and all over the square root of 95. So this is the simplified numerator of my complex fraction. So now let's go ahead in different color. Let's do, oops. Let's go back. Let's do this denominator here. And so we have 1 over 1 minus, and this is actually 2 times negative 9. This is the product, so I'm already taking the product of square root of 5 times square root of 19. So I already have this over the square root of 95. So the two things I need to find a common denominator for are 1 and the square root of 95. So the only thing to really do is, again, to use the square root of 95 as my common denominator. So I have to take 1 over 1 times, well, how am I going to get to a denominator of the square root of 95? I'm going to multiply by this weird looking 1. And then I'm subtracting a negative number, so I'm going to be adding 18 over, and I already have this denominator over here. So my final answer, now that I can combine these numerators, I have square root of 95 plus 18 over the square root of 95. So this is my simplified denominator. So I've simplified the numerator and the denominator of my complex fraction, and now I'm just going to evaluate, see what else I can do. So I'm going to put them all together. And something cool is going to happen here, which you'll see in a second. Plus 18 over the square root of 95. And you may already be seeing it, but both of these are over the same denominator. And so when I multiply by the reciprocal, which is how I divide fractions, these are going to end up canceling each other out. So what that looks like is 2 square root of 19 minus 9 square root of 5 divided by square root of 95. And I'm going to multiply by the reciprocal. And as you can see, here we have the square root of 95 divided by the square root of 95, which of course is just 1. So these cancel out. And I'm left with 2 the square root of 19 minus 9 square root of 5 over square root of 95 plus 18. So I think this is a lot prettier. If aesthetics were extra credit, I would be getting extra credit for this problem, but let's just, to make sure that we did all of our simplification correctly, let's just go plug it into the mat tool. And this takes a minute to delete because I don't know how to delete the whole thing at once. Okay. 2 square root of 19, get my cursor out from there, subtract 9 square root of 5, get my cursor out from under there, divide that whole thing. How did I end up with another parentheses up in the numerator? But somehow I did. Square root of 95, and then I'm going to add 18. Okay, so as you can see, that was a much cleaner, prettier answer. Either one works. I hope that is helpful to you in working through the problems in section 3.5b. Thanks.